Thank you so much for pulling out your time and watching this video on generative AI. So now let's try to understand the genesis of generative AI, or if you are a beginner for Gen AI, so what exactly is this? In order to get a deeper understanding, so I'm trying to make this particular lecture. So I'm Kant, so I will be walking you through this entire session. So please try to bear with me. So sorry in case if I trouble you with your time and all that. The very first one is like generative AI. Yes, we all know we are using ChatGPT, we are using Stable Diffusion, we are using Gemini, we are using Copilot, we are using Cursor, so on and so forth. There are various applications of generative AI. We know that. Now, this generative AI falls under a branch of deep learning. So this generative AI actually falls under a branch of generative AI. You can ask me, can't we need to build it only through deep learning? If I want to say it, the answer is not really yes, the answer is no. So the generative AI can be done even with machine learning. So, but deep learning is a branch of machine learning. So deep learning is a branch of machine learning. And whereas machine learning is a branch of AI, so again under AI, you have multiple branches, like we have narrow AI, we got artificial general intelligence, we got super AI. Now, within our generative AI, which is a branch of deep learning, we have two different models, a discriminative model and a generative model. What exactly meant by a discriminative model is, so now you are started watching a lot of YouTube content. For example, every day you try to watch 10-15 videos. So by listening to my video or by listening to some other video, you are able to discriminate, hey, this guy is doing good or this guy is doing bad. You are able to make a discrimination. So we are able to call it as classification. So I'm trying to say male or a female, or I'm trying to say cat or a dog. So even in the olden days, so our phones are able to say, hey, this is a spam email or this is a non-spam email. After, as we are traveling with our phone, nowadays, it's not just saying spam or a no spam. It is trying to able to write an email for you. So it is generating. So even if you take a kid, initially they start going with discrimination. They can see the faces. They can say, hey, she may be my mother or he is my father. They're able to start discriminating. After a period of time, they start generating, they start speaking, they start drawing, they start using their voices. So all this, so we call generative model. So initially, so like most of the time, data scientist or ML or even DL, so by using these areas, we used to start performing discrimination. We used to say, hey, this guy is writing a bad words in the Facebook and it blocks that particular user. Or this guy is trying to, he means like he's uploading the wrong images in the Facebook, it's going to block that user. So it is able to discriminate what is a right image and what is a wrong image. Our models are able to do it. Now, our models are able to start generating. What exactly meant by generative AI in simple? So, if you are able to give one part of the data, if you are able to give one part of the data, it is able to generate another part of the data. So, it can generate another part of the data. So, if you are able to give one part, it is able to generate another part. So we are able to call it as what? Generative AI. Now, in order to just imagine, now even if you look at the discriminative model or a generative model, so they are possible, means like the regular ML is possible. So I'm not going into a lot of technicality. The regular ML is possible. So like we can use machine learning to perform discrimination on a very simple tabular data. If there is a structured data like sales, profits, this kind of structured data, yes, I'm able to use machine learning and I'm able to perform discriminative models. Now, even if there is a tabular data, so like I'm able to perform generative models using forecasting. So if I'm able to give one part of the data in the forecasting, it is able to generate another part of the data, discriminative model. Now, if I want to use unstructured data, what is unstructured data? Maybe text. So I want to take a text data, I want to build a discrimination. So I cannot able to do it with the help of the regular ML. I want to use the help of natural language processing. So what we do, we take NLP, natural language processing. So with the help of NLP, we are able to take the text data and we are able to make it into a structured format, and we are able to use ML to perform discriminative model. Not really. Now I want to make my models to understand how someone is speaking. It need to understand the language. It need to perform image recognition, or it need to perform all this kind of activities. Then they started developing deep learning. So what is this deep learning is? It is a complete study of ANNs. So what exactly ANNs are? Artificial neural networks. So if you take a human can learn anything. So now my next video going to be on ANNs or artificial neural networks. But what is this ANNs are? Humans can learn any sort of information. Let's take a simple example. Now, when I started drinking a black coffee, I really hated it. But over a period of time, as I keep on drinking black coffee, it's the same black coffee, same taste, same person making it. But the very first time when I drank it, I really hated it. So like after drinking over a period of time, I started loving black coffee. And even after that, I got addicted to a black coffee. Now I cannot go with the smaller sizes. I want to increase the sizes. Now humans are learning irrespective of the data. So the coffee, I don't like it on the very first time. But keep on taking the same coffee multiple times, you start liking it. So take anything. You hate gym, but start going to a gym consistently, you start liking it, you get addicted to it. So take the topic of this data science or AI or ML or Gen AI. So by going over a period of time, you start learning it. You start making, you feel it easy. There's nothing in this, man. It's boring. Now humans can learn any complex information. Now, in order to recognize an image, instead of using ML, I'm using DL. If I want to understand a language, instead of using ML, I'm using deep learning. Now, in the similar way, now we are able to perform a wonderful activities of recognizing the images, understanding the languages. So now we are able to do a very good amount of discriminative models. If you take Google, or they have their mobile net, or even if you take our phones, they have our very good discriminative models. They can recognize based on our recognition, discrimination, they can identify whether we are the owner of the phone or not, discriminative model. So under this discriminative model, again we got two categories. So one is deterministic model and a probabilistic model. So what exactly meant by a deterministic and a probabilistic? In simple, for a fixed input, you get a fixed output. So for example, A value equal to 3 and B value equal to 2. For a fixed input, you are getting a fixed output. And if you are able to take a probabilistic model, for the same input, you may get varying outputs. Example, take stock market. So now the same money, the same stock, if you go and invest it, you don't get the same money back. You're going to get a varying profits, or you get a varying results out of your stock market, probabilistic. Now deterministic is for a fixed input, you're getting the fixed output. Now generative model falls into a category of, so our generative models like ChatGPT, or if you take image generation models like Stable Diffusion or Midjourney, they fall into a category of they are generative models, or we say generative AI. And under this generative AI, they are probabilistic in nature. That's the reason, go back to ChatGPT, start giving one text. For the same text, or so we call the text as what? Prompt. So what you are trying to teach, or then saying teach, what you are trying to ask your AI models, we call them as prompts. So you are saying, hey, I want a Python code, prompt. Now you are using prompts, so the same prompt, but you are able to get a different types of output. The reason why you are getting different types of output, because of its nature, called as probabilistic in nature. So because of this probabilistic nature, there is one more pain area for big companies. So we call it as AI hallucination rate. So, or we call it as hallucination of your AI models. What exactly meant by hallucination of your AI models are, so even though you may ask a question to your AI model, even though it doesn't know, it is able to start giving an answer that it knows it. So we call it as hallucination. So it is able to imagine it and it is able to give you some answers. We call hallucination. Now the goal of, now currently most of the Gen AI engineers are working around how we can reduce the hallucination rate. And why companies are working on taking a model around, 8 billion parameters or 60 billion parameters or 170 billion parameters or 405 billion parameters. Why they are trying to build a model around big billion parameters are in order to reduce your hallucination rate. So now your probabilistic models are having a problem of HR. So what exactly HR stands for? Hallucination rate. And not only hallucination rate, there is one more problem with your probabilistic models. So probabilistic models are what? They are trying to be creative in nature. So now how they are creative in nature? So based on the particular input, so what is the maximum probability I'm able to allocate? So now these probabilistic models are creative in nature. That's the reason I can use generative AI models for the sake of creativity. For example, hey, can you place a guy on a moon, so drinking coffee? So it is creative. So now I'm just asking, it's more like an artist. Hey, for example, can you write me a blog? Creative. Or can you write me a title for my YouTube video? Creative. Can you create me a thumbnail for my YouTube? Creative. Can you, for example, based on this particular problem, can you solve it? Creative. So creative doesn't mean it need to be accurate. So creative doesn't mean it need to be accurate. So now this generative AI models are creative, but we cannot say they are damn accurate. They may be or they may not be. That's the reason they are trying to say, hey man, so like what are the answers we are giving? They may not be accurate. So there may be accuracy or there may not be accuracy as well. So in order to increase the accuracy, what they are doing, they are increasing the number of parameters. So in simple, parameters, I don't want to go into this topic, but in simple, if you take a ANN, for example, I'm taking 4 nodes, and if I'm taking 3 hidden layers, and if there are 2 nodes, so 4 multiplied by 3, 4 3s are 12, and 3 2s are 6. So it's going to be around again, they're going to be 4 3s are again, they're going to be 1, 2, 3. 3 biases plus 2 biases. So 12 plus 6, 18 plus 3, 21. So overall, these are 23 parameters. Normally, this is called as a neural network. I don't want to go into this topic. This is called a simple feed-forward neural network. So this is a simple artificial neural network. So inside the simple feed-forward neural network, you have 23 parameters. Now the models like ChatGPT or the models like Llama 3.1, there are 4 not 5 billion parameters. Now these 4 not 5 billion parameters need to be optimized. So that's what humans do. Now while I'm doing an activity, while you keep on doing a same activity multiple times, the neural wirings going to update. So they're going to fine tune. That's the reason someone is slapping you. For example, your newly born kid. No one slaps a newly born kid, maybe 1 or 2 year old. So he's doing a lot of, maybe like he's a very, a naughty kid. So like he's keep on doing means like, you know that what kind of work, right? Naughty works. So like you just give him a small slap. They start crying. So like you're looking at them with a very angry face. They start crying. So now the same thing over a period of years, if you keep on slapping them, or if you keep on beating them, if you keep on being angry, they get used to it. So why? The neural activations going to be keep on optimized. That would be a right word. So they keep on getting optimized. The same way, so your generative AI models, until we get a good accuracy, until we get a good satisfaction to a human, so we are keep on optimizing. So in this case, 23. So in the case of your ChatGPT, more than 170 billion. If you're in the case of Llama, it's close to 405 billion. So now I'm not discussing into this topic. We'll be learning it later. Now, what are the generative AI models we are learning? They fall into generative models and they fall into our probabilistic models. So probabilistic models are working towards what is that hallucination rate, and they're going to work around. So we need to work around reducing the hallucination rate, and there is a creativity. Based on the kind of activity we are working in, we can control the creativity levels. So we can control the creativity levels of your Gen AI models with the help of a parameter called as temperature. So by using a parameter called as temperature, we are able to control the creativity levels. Now, let's get into this particular generative model. So within this generative models, there are again 2 types of generative models. One is text-based generative models, or I can say text-based Gen AI. And the another one, we call it as vision-based Gen AI. So within your text-based Gen AI and vision-based Gen AI, again you have 2 categories. Within vision, I can take a video or I can take a image or a video-based Gen AI. I can do it. Not only that, so if you are able to give a text, we are able to generate an audio. If I'm able to give a text, I can generate a video. If I'm able to give a text, I'm able to generate an image. So if I'm giving a text, I'm generating a PowerPoint presentation. Anything, I'm able to do it. So now, again, these are the two categories: text-based models, vision-based generative AI models. Now, how this text-based generative AI model started, again, there is a very big history if I want to speak about it. So there is a history like initially we got deep learning models like LSTMs. So we got long short-term memory cells. They started stacking the combination of LSTM cells. So one sort of LSTM cells are acted to encode the information. Another sort of LSTM cells are used to decode it. So in this way, they started performing language translation. So while they are doing that activity, so your language translation is not that great. So the translation is not that amazing. So now why is while we are translating, while I'm translating, Rama is a good person into some other language, I need to give more importance to Rama. So while I'm translating Rama, I need to give more importance. I need to give more importance. Good, I need to give importance. So based on the word I'm translating, I need to give more importance. So for that reason, hey, this encoder decoder models are not that amazing. They started developing another type of text-based models called as attention-based models. So these attention-based models, what they have done, while I'm translating Rama, I'm giving more attention or importance to Rama. So again, this is all a neural network concept. So now even that's not that amazing. Now what they have done, so there is a research paper released in 2017. We all know that story called as Transformers. So by using that research paper called Transformers, what is the breakthrough of Transformers are? Now they got an idea. If each word, so for example, let me show you. If each word is able to communicate with other words, if each word is able to communicate with other words, so how wonderful that going to be. So now what exactly happened? I arrived at the airport or I arrived at something else. So instead of just trying to give the suggestions based on, now even in our phones we have the suggestions, hi, you're able to get how. So or you're able to get that suggestion. So they are not pretty much like LLMs, or we cannot say they are our generative AI, but we are using even that is also a kind of generative AI. We call conditional language models. So we call it as what? CLMs. Conditional language models. Whatever the language models we are using right now, ChatGPT and all that, they're called as large language models. Now in the conditional language models, if there is a word called as hi, so there is a chances of getting a word how. If there is a word called as how, there is a presence of getting are. It's nothing but probability. Now each word is trying to communicate with other words, so to understand about itself better. Now I is communicating with arrived, at, and the, so all the different words to understand about the importance of why in the entire sentence. So we call it as understanding the context. That's the reason. If you go back and use your regular Google search, based on the keywords, your search engine is dependent. Current Google search engine is dependent on the keywords. Go back and use the same ChatGPT. The way you are getting the answers are dependent on the context. So the overall sentence context, it is dependent. That's the reason the way you are changing the context, the way you are formulating your sentences, the way you are feeding the information to your LLM models or your generative models are very important. That's what we are calling it as what? Prompt engineering. So with the help of prompt engineering, even we are able to make our LLM models to perform well, or we are able to reduce the creativity levels, and we are able to reduce that hallucination levels, and we are able to get a very good amount of performance. Now each word is trying to understand itself. How each word can understand about itself? If I go a bit deeper, so they are able to understand about itself with the help of a mathematical equation called as self-attention mechanism. So we call it as what? Self-attention mechanism. So with the help of self-attention mechanism, but normally in our regular LLM models, we mostly use multi-head attention, or we use masked multi-head attention. So by using that self-attention mechanism, or we can say self-attention mechanism or multi-attention mechanism, we are able to make each word to understand about itself in a better way. That's what we are trying to do. Now, let me get into this. Now, within the generative models, we got text-based, attention-based models, and then we got transformers. So what exactly, this is the breakthrough. So what exactly transformers are doing? So transformers are helping us to understand the context better. So that's the breakthrough. So when it is able to understand the context better, so how it is able to understand the context better? With the help of a mechanism called as self-attention, or we can say self-attention mechanism, or I can say self-attention formula in simple. So with the help of a self-attention formula, each word is able to understand about itself in a better way by communicating with other words. Now, with the help of transformers, again, we got two different types of models. We got a BERT model, so we call it as encoding models. What is auto? We call it as, there are two categories, auto encoding models and auto-regressive models. So GPT is an example of auto-regressive. So BERT is an example of auto-encoding. What is auto-encoding? I'm saying Rama dash person. Encoding. Now it is able to compare, hey, Rama is a good person. It is able to identify that word. Auto-encoding. Auto-regressive. So Rama is a good person. So he used to read every day. So now I just said Rama is a good person. So your GPT models or your neural networks are trying to generate. So now he's a very good person because he used to start completing his assignments on time. He's able to go to the school on time. He's able to give his best in the school. That is what your generative AI is doing. You're just going and asking, hey, can you write me a code for data structure set algorithms? It start writing it. Hey, can you tell me about six-pack diet? It start writing it. So now we call auto-regressive models. That's what GPT models are. Now, we just learned about text-based. Now, in the similar way, we got vision-based. So initially within the image, we got convolution neural networks, or we call CNNs. So we used to use CNNs. So within the CNN architecture, we have a layer called as a convolution layer. This convolution layer helps us to desample the size of your metrics or the image. So whatever the image you're feeding in, we are able to reduce the size of the image. Convolution 2D, we call it as. Now, they started using convolution 2D transpose, convert 2D transpose. So by using this convert 2D transpose, we can start generating the image. Now they started generating the images with the help of models called as autoencoders. So they started developing image-based generative AI with the help of autoencoders, with the help of GANs, generative adversarial networks. So with the help of variational autoencoders, we have types, neural style transfer, we have various categories. Now what exactly this image-based generative AI is doing? If I'm able to give a blurred image, it can convert a HD image. I'm trying to shoot a normal photo. It can make an amazing photo out of that. So with the help of my autoencoders, GANs, and all this. Now what they have done, so now if I give an image, it can create a beautiful image. It can enhance it. But they got an idea. Why can't we, where is the spare? Yeah. Why can't we merge this transformers? Yes, this one. Autoregressive, or I can say transformers. Why can't I take this transformers and why can't I add it into this image generation? So if a guy is trying to give a text, so now they can understand the text better. In the olden days, what is the challenge? They cannot understand the text better. Why? They failed at understanding the context. So in order to understand the text better in the olden days, before ChatGPT, what they used to do, they used to take a sentence, they used to break it down into tokens, and they used to identify term frequency inverse document frequency. They used to feed it into an ML algorithm. But now they can understand the context better. When they can understand the context better, why? Our limitation is only with, if I give an image, generating an image. So instead of doing that, if you are able to ask a question in the text, we are able to generate a mind-blowing image. So that's where you got your diffusion models, you got Glide, you got your unit architecture, you got your clip architecture and all that. So I'm not going deep into that segment. So in this way, we are able to have this segment, we have it. Now, if I want to build a generative model, so now it's simple. If I want to build a generative model, it's a very aggressive task. If I want to go and build a generative model, it's a very aggressive task. So that's the reason what people are doing, they're relying on. So man, can I build this generative model? Yes, you can build it. But in order to build it, it's take a lot of money. Why you want the money? So now it's more like a human. So artificial neural networks, they don't get trained in a least amount of time. We want to provide a high specification computer. We want to provide GPUs. We want to provide data. We want to write the code in such a way that it can learn it. So like we are able to minimize that losses and all that concepts we have it. Now that's the reason building generative model from the scratch is a very big task. That's the reason what people are doing. So in order to build a model, minimum to minimum, generative model at a level of GPT, at a level of ChatGPT, at least minimum to minimum, you need to have 70 to 100 CR based on the resources or based on the other sources. They are saying it need to have minimum 70 to 100 CR of investment to build a ChatGPT level of LLM model, or even a ChatGPT level of, or Gemini level of model if you want to build it. That's the reason what people are doing. They are relying on a concept called as transfer learning. So they are relying on a concept called as transfer learning. What exactly meant by transfer learning? So transfer learning in simple is nothing but you are trying to take the intelligence of ChatGPT, or you are trying to take the intelligence of Gemini, and you are trying to customize it to my healthcare company, or I'm customizing it to banking, or I'm customizing it to aeronautical, or I'm customizing it to manufacturing, or I'm customizing to some etc. and etc. So we call it as transfer learning. So in order to perform, so whenever you're performing, in very simple, what is a transfer learning? So now there is a good car driver. So now he's a very intelligent car driver. He's a very professional car driver. Now you want to use him into a military. So I want to use him into military. Now what they do, they don't train him from the scratches of car driving. They try to customize him for the sake of military. In the similar way, already these ChatGPT models have the intelligence. Now they want to customize it. So in order to customize it, what they are doing, they are using concepts of, now why they want to customize, these generative models are having a problem of hallucination and they can make mistakes. So I want to control that. So in order to control, we are using one of the technique called as prompt engineering. So now by giving the right word, so what is happening? They are able to understand the context better. So we are doing prompt engineering. So now, or within the prompt, we have types. And again, we got RAG, Retrieval Augmented Generation. With the help of RAG architecture, we are able to make my models to behave better. So something greater than prompt engineering is RAG. And after RAG, we got another one, which we are able to call it as our fine tuning. So I'm trying to take the GPT model and I'm fine-tuning it for a specific activity. So GPT models can do coding, text generation, or they can do question answering. I'm taking the data only of question answering of a healthcare and I'm fine-tuning especially for healthcare. So that's what our Palm 2 is doing. So now Palm is a model from Google. So like they fine-tuned the Palm model for especially medical Q&A. We call Palm 2. So fine-tuning. Or we can perform pre-training. So now you are trying to have a huge amount of data. You are customizing the entire GPT model for healthcare pre-training. So these are the ways we have it in lines of your transfer learning. Now what most of the people are doing in Gen AI is they are trying to learn mostly prompt engineering part. They are not even learning other areas. They are just trying to spend prompt engineering part. They are trying to feel, hey, I'm using Gen AI and I'm like a rocket guy, so I'm like a scientist. Not really. So like prompt engineering is more about what words to use to make your models to give the best. But really, they don't give the best. So sometimes. So now that's the reason we are using RAG, Retrieval Augmented Generation, or we are using fine tuning, or we are using pre-training. And beyond this, now we are stepping into another area called as agents. So by using this Gen AI models, what I can do, now the Gen AI model is more at a completion of a text. Instead of completion of a text, I want my Gen AI model to be more task specific. It need to complete a task. I'm just giving an activity. Come on, write a code on Python. We need to do it. We call them as agents. So now I will be doing them on the next lectures. I hope you got some high level idea of it. Now, if you're planning to learn Gen AI, any person, so like I'm a non-technical guy, if you have some Python knowledge, you can work on prompt engineering and RAG. But if you want to work on fine-tuning and pre-training, you need to have a knowledge of ML and you need to have a knowledge of DL. So without the knowledge of ML and DL, you cannot work on fine-tuning and pre-training. I hope you got some good idea about what is Gen AI. So now in simple, Gen AI is if you are able to give one part of the data, it can start generating another part of the data. We are calling it as Gen AI. Even if you see this image, that's what this image is. Now initially we got our discriminative models. So what are discriminative models? I'm giving various images. So we are giving a label what these paintings are. my kid is able to start discriminating. Hey, this painting is this, Papa, or this painting is that. He's able to discriminate it. And then we got generative models. What are generative models? If I'm giving one part of the data, they can start generating another part of the data. They can make it good or amazing, or they can add some creativity and they can do it. Generative models. I hope you got some good idea of it. If you like this content, please do share your views in the comment section. If you like something more technical and more deeper topics, please do let me know in the comment section. I can just work around it. Thank you so much. If you really like it, please do like and subscribe. And thank you so much for spending your valuable time with me. And signing off, Ka.